Welcome to the course orientation for Math146 Calculus 1 under the Mapua Modular Academics. Mapua envisions itself among the best universities in the world, and as such, it is committed in providing a learning environment in order for its students to acquire the attributes that will make them globally competitive. It shall engage in publishable and/or economically viable researches, developments, and innovations. And it shall provide state-of-the-art solutions to problems of industries and communities. Here are the educational objectives that are addressed by the different engineering programs the university offers. A number of the engineering programs offered by the university has accreditation given by the Accreditation Board for Engineering and Technology, or ABET, a US-based accrediting body. And among the ABET student outcomes, it is number 1, which is the ability to identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and mathematics that is being addressed by this course. And among the PTC, or the Philippine Technological Commission, and CHED students' outcomes, it is number 1 student outcome that is also addressed by this course. So this course is Calculus 1 with code of Math146, a 3-unit course that would bridge you through the concept of limits, continuity, derivatives as applied to algebraic and transcendental functions in one variable, and extending the concept, applying it to multivariable functions. Under the Mapua Modular Academics, this course is divided into 3 modules. Module 1 is on ordinary differentiation of single variable, algebraic, and transcendental functions. And the module course outcome is for you to be able to differentiate single variable, algebraic, and transcendental functions at the end of this module. This module covers 4 weeks, running from week 1 to week 4. The different teaching and learning activities that will be shared with you are the micro video lectures, the video lecture links and reading links from the textbook, and solve sample problems. The assessment tasks are as follows. We have 4 assessment tasks for this module. We have the PKC, or the Post Knowledge Check on ALEX on the area of algebra and trigonometry. We have homework, or HW, problem set, or PS, and long exam, or LE. These assessment tasks are given the corresponding weights. PKC for 15%, homework 15%, problem set 25%, long exam 45%, for a total of 100%. To earn a passing mark for this particular module, the student should obtain at least a weighted average of 70% for this module. For module 2, we have the applications of ordinary derivatives, and it is expected that at the end of this module, you should be able to solve application problems involving the derivatives. Now, this module will run from week 5 to week 8. And again, for the teaching learning activities, we will have micro video lectures, links to video lectures and readings from our textbook, and solve sample problems. The assessment tasks in this module we just covered the following: PKC again on Alex on the area of solid geometry, homework, problem set, and long exam, correspondingly having weights of 10%, 20%, 25%, and 45%, again for a total of 100. And as in Module 1, for a student to earn a passing mark in this module, he or she must average at least 70% in the module. Module 3 is on the derivatives of multivariable functions with application. At the end of this module, you should be able to differentiate multivariable functions as well as solve application problems involving partial derivatives. This module will run from week 9 to week 11. And for the teaching learning activities, again, we will have micro video lectures, video lecture links and reading links from our book, and solve sample problems. The assessment tasks, again, we covered PKC on Alex, but now on the area of analytic geometry. Then we still will have the homeworks, problem set, long exam, with weights given as follows: 10%, 20%, 25%, 45%, for a total of 100%. And again, a student should average at least 70% in all of these assessments to earn a passing mark. Okay, let us go through the different assessment tasks given in this course. We have Alex in terms of initial knowledge check and post-knowledge check, or IKC and PKC. Alex stands for Assessment and Learning in Knowledge Spaces. These exams aim to assess pre-knowledge and post-knowledge of students on some topics in algebra, trigonometry, solid mensuration, and analytic geometry that are essentials in calculus. We recognize the fact that incoming freshmen came from different senior high schools spread over the country, and as such may have different baselines with regard to knowledge in algebra, trigonometry, solid mensuration, and analytic geometry. It is in this light that the department opted to adopt Alex Precalculus as an academic support system to bridge the gap between what the students know about the above-mentioned areas and what we expect them to know on this. Now, another assessment task are the problem set, or PS, and online assessment, or HW, or homework. And these are formative assessment. These are formative assessment that will gauge the students' preparedness for a long exam. So these are given prior to the schedule of the long exam or the module, final exam. And lastly, we have the long exam, which is, of course, a summative assessment that measures the achievement of the students for the given course outcomes. For our textbooks, we will have two: Calculus Early Transcendentals, 11th edition by Anton, and Calculus of a Single Variable by Larson and Edwards, 2018. Both of these books are in Metis, and you can easily access them. Okay, please take time to read again or go over again this presentation if there are things that are not very clear, and if there is a need for you to do some consultation, then you can raise your concern through Blackboard discussion board for your section. Okay, thank you, and please be guided accordingly.